Saxon's Trig, lesson 60, page 392, is about factorable trigonometric equations and then loss of solutions caused by division. As it implies in its title, you're going to be factoring trig equations. So example 1 gives us tangent squared of theta minus 1 equals 0. Now, instinctively, I want to change the 1 to the other side and make it be tangent squared equals 1. And then how do I undo a squared? I square root of 1 stayed. So this should be tangent theta equals 1. Oh, I can graph that. But my problem is by doing this, I lose a solution that I should be keeping. So if it is factorable, factoring should take place before algebra kind of solutions. All right, so can I split this into two parentheses equal to 0? Yes. Tangent squared is written as tangent theta. And then 1 splits to 1 and 1. Now there is no middle term. That tells me that one sign must be positive and one sign must be negative. And then I double check. A positive times a negative, yes, it gives me a negative. This is factored correctly. So when I solve, both parentheses are set equal to 0. So this one, tangent theta equals -1. And in this one, tangent theta equals 1. Oh, see, here's one of the solutions. That's where I got before. This is the solution I lost. So when I go to graph, I realize that I've got both a positive and a negative. So it's landing in all 4 quadrants because 2 for the positive, 2 for the negative. And I did fail to write down in that original question that they did tell me my boundaries are between 0 and 360. And again, I need that to know where to stop. So now that I know I'm only going one time around, we can find our answers. Tangent, TOA. So the opposite for the negatives will be -1 here, -1 here. The adjacent is the implied 1. And that makes the hypotenuse's root 2. So what degree goes in here? 45. Is it the same when I do this one, opposite over adjacent? Yes, the opposites are +1. The adjacents are the 1. Just a second, I feel like I did. Oh, I labeled it automatically, but I think I gave the implication that this -1 was in the bottom 2, and it's not. Negative would not have been in all or take. So for the negative solution, it's here and here. These would have been the original 2 that I would have gotten. And then for the positive one, it's quadrant 1 and quadrant 3. Hypotenuse is still root 2 no matter what we do. And we know it's still going to be 45 degrees. But my reasoning here is that positive over positive is positive and negative over negative is positive. Now you see why we have all 4. So we've got 45 degrees in quadrant 2. We are shy of 180, so that's 135 degrees. Quadrant 3, we're past it by 45 degrees, 225. And in the 4th quadrant, we're just shy of 360 by 45, so that should be 315 degrees. And that's all of the solutions between 0 and 360. Okay, example 2. Sine squared theta minus sine theta equals 0. Now this one is easier to see that I need to factor it. Sorry, I was debating which way was best way to factor it. And my brain was also saying I would have only got, yes, I've said everything I need to say about that. All right, so let's try to factor this. What we're going to do is pull a sine theta out because this one has 2, this one has 1. I can't factor that into 2 parentheses, but I can pull a sine out of both. So this one leaves a sine theta minus, and because I pulled that out, I need a placeholder of a 1 equals 0. Now it's factored. So for this one, sine of theta equals 0, or sine of theta equals 1 if I move it over to solve. Okay. Sine is opposite over hypotenuse, opposite over hypotenuse. This implies over 1, this implies over 1. When we graph, where is our sine? Oh, again, boundary between 0, 360. Did not look or tell you, but it's there. So all, it's positive. Students, not take or calculus. So the opposite should be 0. The hypotenuse should be 1. Ooh, that's a quadrantal because I have moved not up, but over. So this has to be a 1, this has to be a -1. All students, yeah, that should both be my positives. Yes, because of the 0. Yes, yes. So what is the degree if I am moving over but not up? Well, this is 0 degrees. Now, here is a thing. You can say, well, am I supposed to write the 360? And technically, in what they're giving you, you can be equal to the 0, but you must remain less than the 360. So no, I will not put 360 in my answer set, even though this line is 0 and 360. Here, the line I'm moving over but not up. So this is 180 degrees. And now for the other one, I would not, oh no, it's also positive. Okay, so all and students, my opposite is 1, my hypotenuse is 1. So if these share, then I'm not moving over at all here or here. So if I don't move over, but I move up, this is 90 degrees. And the same thing here, I don't move over, but I move up, that's still 90 degrees. So I have 3 answers that fall between the 0 and the 360, but don't include the 360. Example 3, cosine squared theta equals 1, and this time I'm going to go ahead and say that I'm between 0 and 360. I have looked to make sure. Okay, this again looks like I might be able to square root both sides, but if I do that, if I don't attempt factoring, I'm going to lose solutions. So to factor something, I need it on the same side equal to 0. So I move the 1 over by minusing it. Now can I factor into 2? Cosine theta, positive and negative, or 1 and 1 makes 1. And then no middle term, 1 positive, 1 negative, check. Positive times negative is negative. Good, I'm good. So cosine of theta equals -1, and cosine of theta equals 1. Cosine is ca, adjacent over hypotenuse, implied 1s, adjacent over hypotenuse. So my first graph will be, now cosine is negative here, so not in all. Students take care, or the one that is calculus. So it's going to be in quadrants 2 and 3, adjacent -1, hypotenuse 1. And if these share, then this must be zeros. So I am going over but not up in either direction, so I am stuck at 180 degrees for both of those. And then for this one, cosine is positive, so all and calculus. Now adjacent is 1, hypotenuse is 1, same problem, I get zeros for the other side. So I am traveling over but not up, so that is the 0 degrees. Will I use the 360? Just a second, I'm checking that answer and I should be getting, oh yes, sorry, I just looked at it backwards. They flipped the order to write them in order and it threw me for a split second. So should I use the 360? No, same reason as we said before, it's indicating less than 360, so I can't use that one. Okay, that's the factorings. Then in part B, they talk about kind of what we've already just said, losing solutions, but this isn't for like the random solvings where I said I felt like I should solve it that way algebraically. This is slightly different. So in the next example 4, they give us 2 sine x cosine x equals sine x. and again between 0 and 360. Okay, so if I do not attempt to factor, which I should always do first, and I could just go, oh, I can make my life really simple, because if I divide both sides by sine x, oh, look, I've lost part of the problem. Doesn't that make it easier? That would mean that cosine x would equal 0, and 0 divided by 2, so cosine x equals 0, quick and simple. But no, because then I've just lost any solutions that would have involved the sine x. So just like in section A, always factor first, never make something disappear. So 2 sine x cosine x, and I want it equal to 0 to try to factor, so minus sine x equals 0. And then we're going to pull the sine x out. So that leaves 2 cosine x minus, and just like before, I need the placeholder of 1 equals 0. So we can set sine x equal to 0, or cosine x equals, and we move this over and make it positive 1 and divide by the 2. So now we have what it equals. So sine is opposite over hypotenuse, implied over 1. Cosine is ca, adjacent over hypotenuse. Where will my sign be positive? All and students. Opposite will be 0. Hypotenuse will be 1. Oh, again, implies ones, quadrantals. So I'm moving over, but not up. So this one is 0 degrees. This one is 180 degrees. Not the 360, as we've already said. Cosine will graph its positive. So in all, not students take, but calculus. So adjacent is 1, hypotenuse is 2. Oh, this one's different. This makes these root 3. So opposite this is 60 degrees. So for this first, that's 60 degrees. And then this one is shy of 360 by 60. So that gives it 300 degrees. And there is your 0, 60, 180, and 300. They always list them in order. I'm just boxing them.